Okay. Anyways, yeah. Sorry. Thanks. Also. Okay. So the question is, right? So all of these 4 different systems use gradient descent, right? So the question is gradient descent, right? Like, what is it actually doing, and is it actually good? So I think. So the big names in machine learning. So if you've probably heard of these names, maybe. Has anyone heard of Geoffrey Hinton? No? Or whatever. Geoffrey Hinton. Okay. There are also other big names like Andrew Ng. You can search them up. Andrew Ng, Yann LeCun. What are the other? Oh yeah. Ian Goodfellow. I forgot his name. Andre something. I forgot. Whatever. There's lots of names, right? So Geoffrey Hinton is the father. Like we would say, he's the father of backpropagation, of gradient descent. Oh wait, technically backpropagation, but whatever, right? So he in like I think 50, 40 years ago, I think maybe 30. He was the one who published a paper on neural networks backpropagation. So he's the kind of the father of all neural networks. Andrew Ng, well, he does lots of courses like Coursera and stuff, so he's extremely well known. Yann LeCun is the founder of CNNs, convolutional neural networks. Ian Goodfellow made GANs, generative adversarial networks. I forgot what Andre did. Whatever. Yeah. Anyways, so Geoffrey Hinton was the guy who made, right, so he was the one who said to use gradient descent on neural networks, right? Remember neural networks, deep learning, all the stuff, the hype, and right, you can do everything with this, learning all the systems, right? So this is a neural network. We coded one a few weeks ago. Yeah. Wait, is it? It's super. Oh, good. Thank God. Okay. Anyways, we coded a neural network, right? And remember, gradient descent tries to learn the weights, right, of each layer. Okay? And backpropagation is the system, right? Backpropagation is the method or algorithm. So step 1 is to remember so step 1 is to go forward, compute some loss, right? Some loss function, and then it backpropagates. So it goes backwards and updates the weights using gradient descent. Right, so Geoffrey Hinton was the guy who published a paper on this, and everyone was like dissing him, like saying this will never work, right? Backpropagation is never going to work. And then, it obviously works, right? Neural networks are used everywhere now. Spam classification, self-driving cars, all of the new stuff, right? Dating apps, I think also, and stuff, right? So, but now, I think recently, Geoffrey Hinton said that he does not like backpropagation, right? He said that backpropagation is creepy, and it's he doesn't like it, right? He doesn't like this system of using gradient descent to learn parameters. So what he's trying to say is, so if I have a child, right, like 2 years old, and if I let them read a book, right, they probably don't know every single word. Right, and if I have a baby, like 6 months, right, and just put it into some system, right, some room, and let it play some games, like if I have like some blocks or something. So anyways, even at 6 months old, this child will probably learn after like 10 minutes to play with blocks, right, 10 minutes. But if I put a reinforcement learning algorithm or gradient descent based systems, it will take 10 years maybe to learn. Right? I don't think so you can actually learn this because there's too much data in the system. If I put a machine into a real room, it's highly unlikely that it will pick up blocks and put it onto each other because there's no creativity within the algorithm. Right? So what he's trying to say, what Geoffrey Hinton's trying to say is that it's because of this culprit, right? Backpropagation. Right? If we have a brain, right? Do you think brains do backpropagation? Right? We trial and error and then we update our neurons or something? We don't do that, I think. Right? Well, we probably do for a little while. So what Geoffrey Hinton's trying to say is we need to find a new method. Right? Delete the whole concept of backpropagation. Right? Delete the whole concept of neural network updating weights. Right? We don't like this. He doesn't like this thing. Right? It just doesn't really make sense. This is not gonna Because if we stay with this architecture for the next 5 to 10 years, right, we will never reach general artificial intelligence, right? General artificial intelligence is the AI you see in TV shows and stuff and movies, the ones that kill the whole earth and stuff. We're not there, right? We're probably like 5%. So in the next 5 to 20 years, if we don't change the system, right, so people have to develop new algorithms and new ideas. If we don't change this system and shake the deep learning community up, then the world is not going to get anywhere. Okay, so that's what Geoffrey Hinton's trying to say. He's trying to say that backpropagation is not good. Well, not really not good, just it doesn't make sense for the future. Okay, so that's general AI. So now we're going to talk about AI cooperation and aggression. Okay, so let's just say that we develop a system, right, not using gradient descent, right? No such thing as gradient descent. We develop some algorithm, some algorithm, okay? We don't know that yet, okay? We don't know. Maybe in the next 5 to 10 years, we're not sure, okay? And this algorithm can learn in a system using lots of data and very fast, right? So this system can be this brain can be similar to a 16-year-old, okay? Just pretend, right? So then what happens, right? In the next 5 to 20 years, what happens if we develop a new algorithm, right, that does better than gradient descent? So I think this was Google, I think DeepMind, if I remember. But so what they did was they let it play a game. So I think it was DeepMind, I think. Right, so if I have a game, so the aim of the game is if I have some food, okay, food is going to be circles, okay? And I have two different people, two different enemies, right? They're enemies of each other, right? And I just put it in this game. So the aim of the game is to collect as much food as possible. And these food, right, the circle things move around, right? They can move here, move there, whatever. Just pretend this as a hunting ground. Okay, some hunting ground. So what Google found was that if you have tons of food inside a system, these two predators will cooperate with each other. Okay, so they will cooperate if there's lots of food. So they will work together to get food, right? I think it was DeepMind. But then, once there's only one food left, right? They're going to be aggressive with each other, right? They're going to attack each other. Right, you can also attack in this system. Right, attacking, so you can shoot stuff at them. And so what Google realized is that when resources get scarce, the AI will attack. Right, so that's not very good. So I think because of that, they put some stop button on their system. Some DeepMind, they actually put a literal stop button, it can destroy the whole system, just in case if something bad happens. So yeah, they realized that AI systems can be aggressive. Because we tend to think as AI systems, like programming and stuff, tends to be cooperative. But in fact, it can be very aggressive. So we have to be careful. Okay. Oh yeah, we're talking about evolutionary algorithms. Yeah. Oh, Alphago. Yeah. So has anyone heard of Alphago? Yeah, okay, so Go is an ancient Chinese, I think it was Chinese or Asian, I don't know, some Chinese game thing. And what you do is you have some big fat board, right? And so if you start first, I think it's either black or white, I can't remember, whatever. You have black and white tiles, right? And the person starts first, you can put wherever you like, right? You can put it over here, you can put it in the middle, you can put it somewhere, right? There's a grid, right? Anyways. The aim of the game is to score the highest points, right, by blocking your opponent. Right, it's all like chess. Chess is like a sequential game, right? There's always going to be a solution. Go, there is no solution.